We've covered some basics of classes, but let's also talk about some more intermediate topics. There are a lot of features for classes in programming, so you need to get a good handle of these topics. Classes are the backbone of languages like C++, C#, and Java. Constructors and destructors are a special type of function that classes can have. Constructors are run automatically and immediately once you instantiate, or when you declare, a variable of that object type. Destructors are run automatically and immediately once that variable goes out of scope, so in other words, once it becomes destroyed. These are good for initializing and deinitializing our objects and their internal members. Remember how uninitialized variables may contain garbage? There's no default value for variables in C++. If your class contains ints, floats, characters, or other data types as member variables, we don't know what they will store when the object is first created. When we declare our object, we have to remember to initialize all its internal member variables. Relying on remembering is a good way to get bugs, because eventually somebody is going to forget. Utilizing constructors and destructors mean that we do not have to remember. We can make sure that the class initializes and deinitializes its member variables to some safe value. So as an example, on the left we've created a function called setup that initializes the student count to 0. We need to manually call this to make sure that we start at index 0 when we're accessing the student array. If we don't call setup, we can easily access something outside of this array because our student count might be garbage, so we might get something like student number 1000, even though we only have 30. On the right, we use a constructor to initialize that value to 0, so no matter what, anytime we create a new course, our student count is always going to start at 0. So again, relying on the user or another programmer to call setup is just going to be unreliable. With this course class, if it's not initialized, again, it could easily go out of the range of our array, and that could cause a really bad problem. Constructors allow us to initialize our internal member variables to something safe, or even call internal member functions when we first create our object, so that we don't have to rely on the user or another programmer to create it the correct way. Additionally, you can also overload your constructors with different parameters to initialize your object differently based on which information is available at the time. If a variable of this assignment type is declared as assignment 1, and we don't pass anything in, it just looks like a normal variable declaration, everything is assigned to default values, like in this constructor right here. But if we declare another variable of type assignment and pass in a couple of arguments, then the constructor that takes those two arguments in will initialize some of the values for us. It still sets received points to 0, but at least now we have total points and the weight initialized to some value. Note that if we had the constructor with the two parameters, but not the constructor with no parameters, this would make it so that anytime you create a type of variable of type assignment, you have to create it with these two parameters, or two arguments. So, if you have one but not the other, you have to use the one that's available. Now with destructors, there could only be one. It does not take any parameters, and it can't be overloaded like the constructor can. Destructors are called when the object variable goes out of scope and is destroyed. This is especially useful once we get into memory management later. A good example of something we would want to clean up before the object is destroyed would be file IO. So with this class, it requires that you pass in a file name to open a file when you first create this file writer object. And then when the file is destroyed, when the object is destroyed, it closes the output file stream automatically, so we don't have to worry about it. If we had forgotten to close the file before the program quit, we could possibly get corrupted data or lose some information. The constructor always has the name of the object and no return type. It may or may not have a parameter list, but it still needs the parentheses either way. The destructor always has the name of the object, but with a tilde beforehand. Its parameter list is always empty. Static members are an interesting feature of classes. I had a hard time grasping them at first, but these days I use them relatively frequently for a very specific type of class. It's up to you to use static members in a class or not, but let's go over what they are and some uses for them. With normal member variables, every time you instantiate, or create, a variable of that object type, it gets its own set of those variables. But if you declare a member variable as static, that variable would be shared among all instantiations of that object. This might be useful for keeping count of instances of the object, or something else that they all have in common. Okay, so stay with me for a second. Let's say that we're writing a class that wraps the file stream object from the standard library, just like before. We want to take advantage of constructors and destructors to make sure that the file is opened and closed safely, automatically. I'm going to implement a static member variable, but I think it's better to show rather than tell. Okay, so sometimes you want to wrap functionality to add onto it. With the OFStream class, we have to open and then manually close things, but we can write a wrapper to take care of that for us so we don't even have to bother with it. So let's say this is input file. We're going to create an OFStream object, just call it file, and then publicly we'll have our constructor, which will want a file name to open, and a destructor, which will close the file for us. So file.open, and we'll have filename.cstr, because we need to pass in a C string. This function turns a string into a C style string. So we have that, file.close. Now we have a simple wrapper. We can get rid of this stuff. We can instead call this file program log, file information, and file temp file. And we can erase this. Now this isn't going to work because I didn't write like something to take text. We can do that real quick. Write text, string text. And again, strings are objects, so I'm going to pass it as const reference. We'll just say file text end line. So we could say temp file dot write text test. Okay, so we can run this, except I made an error. Let's see, what is it like? Oh, I changed this. Input file, input file, input file, input file. Actually, this would be output file. An input file we would be reading from, and so output file we're writing to. Now, I forgot to make these public. Your constructor and destructor ought to be public. In these cases, we can build and run. And so, I mean, it doesn't show anything right now, but we've at least gotten rid of the need to have a closing. So, close is handled automatically. Don't have to worry about it. What if we want to keep track of how many of these files are open? Because this temp file, it'll be created within the if statement, and once it hits this closing curly brace, it will go out of scope, which means that it will be destroyed. So at this point, there are 2 files. At this point, there are 3 open files. But then back out here, there are 2 open files again, because this one got created and destroyed. So we could create a static counter, static int file count, and then we could basically create some functions to deal with this. So we could create static functions, increment file count, and decrement file count, and let's do int get file count. And I misspelled static. This will just return file count. This will subtract from it. This will add to it. So when we create our file, we're going to call that function. When we destroy our file, we're going to call this function. So it'll automatically keep count for us. And this file count is shared, so while for OFStream, each output file object gets its own OFStream object, they all share this static integer for file count. Okay, now this is going to give me a build error. It's saying undefined reference to output file count. So we have it down here. We have declared it right here. A kind of weird thing about static members is we also have to define it, and we'll define it like this. We have to say its type is an integer, it's part of output file count, and then here we can initialize it. We can't initialize it from the constructor. So if I just took this, it's probably going to complain. Oh, maybe it's not complaining. I'm not sure that that would actually output it, and if we did have it in the constructor, we don't want it resetting to 0 every time we create a new file, because that would defeat the purpose. But now we've set it to 0. We can have, we can call it by saying file get file count to get that number. So files file count end line, and we'll do it after each one of these. We'll do it here too, and then at the end of the program. So let's number this 1, 2, 3, 4, 5. Build. Okay. I also forgot that this is output file again. And run. So, first step. No files have been created. 1 file has been created at this point. 2 files at that point. At this point, 3 files, and then back to 2 once it leaves this if statement. So that's one useful use for a static member. It's kind of hard to explain a lot of uses for static members without getting into something pretty complex to implement. I mean, I could write a program that just shows how to use a static member, but as far as the application of it, it's a little harder to describe. But hopefully this makes some sense. We have our shared count variable. We modify that whenever we create or destroy that object, and it just gives us that extra functionality, a way to see, are there still files open? Maybe we wouldn't want to close the program with a return 0 until we've made sure all the files are closed. Of course, with the destructor, once it goes out of scope here, these files will close anyway, but there could be special functionality. Alright. So, we created a static member variable by adding the static keyword before the variable declaration. Anytime the file count is accessed within any output file function call, the values will be the same. We initialize it at 0, and anytime we add or subtract, that value is shared between all output files. Constructors and destructors are a special type of function that classes can have. Constructors are run automatically and immediately once you instantiate, or when you declare, a variable of that object type. Destructors are run automatically and immediately once that variable goes out of scope, so in other words, once it becomes destroyed. These are good for initializing and deinitializing our objects and their internal members. With static members, we also have to define the variable in addition to declaring it. Outside of the class, we define it by specifying the data type, the class it belongs to, and the variable name. We can also initialize it here. When accessing a static member, we can either access it directly via the object name, so we have output file, then 2 colons, the scope resolution operator, and then the function name. Or we can access it via an instantiation of the object. So we've created a program log variable, and we can access it with program log.getFileCount. This function returns the value of the static int file count variable, so calling it either way will give us the appropriate value. It is good to know about static members, even if they don't make complete sense right now. As with anything, it takes practice, and if you encounter a static member in somebody else's code, you have a rough idea of how it works now. We have used the const keyword in the past to create a variable flag that does not change, as well as to create function parameters that are guaranteed to not change. We can also ensure that an object's member function cannot change the value of the member variables by marking the function as const. If we put const at the end of our function signature, this means that within this function, no members of the class will change their values. Similar to passing values by reference, but not wanting those values to change, the const lets us write functions that operate on some data, but does not corrupt that data in the process. Trying to make a modification within a const function will result in a build error, and it is always easier to fix a build error than a logic error. So how are you doing with classes? We've covered a lot of important topics, and it's important to practice, so how about this time I give you some practice problems instead of just coding. You'll find the solutions to these in the course repository.